In this tutorial, we will be discussing the difference between pressure and concentration equilibrium constants. Remember, the relationship between the chemical equation of the reaction and the concentrations of the reactants and products is called the law of mass action. It is a ratio between the product and reactant concentrations. So if we have the generic formula of A plus B yields C plus D, it's always the products over the reactants. So the concentration of the products are always over the concentration of the reactants. These little letters here are the stoichiometric coefficients in the chemical equation. And then K is the equilibrium constant. So just to practice this one more time, the products over the reactants, SO3 to the second power over O2 to the first power and SO2 to the second power, and that equals the equilibrium constant of 8 times 10 to the 25th, which is very high, which means that the products will be favored. The second one is NO2 to the second power because of the coefficient over O2 to the second power because of its coefficient, and N2. That equals 3 times 10 to the negative 17, which is very small, which means that the reactants are favored. So the equilibrium constant of the reaction in the reverse reaction is a reciprocal of the equilibrium constant of the forward reaction. So the forward reaction, NO2 over N2O4, NO2 over N2O4 is 0.212. If we reverse that reaction, N2O4 is on top and NO2 is on the bottom. That's equal to the 1 over 0.212. The equilibrium constant of the reaction that has been multiplied by a number is the equilibrium constant raised to the power that is equal to that number. So for instance, if we multiply this entire equation by 2, that then changes the coefficient. So this becomes 2, 2 times 2, that comes to 4. So that 2 turns into a 4, and this 1 turns into a 2 because of the differences in the coefficients. The equilibrium constant for the net reaction made up of 2 or more steps is the product of the equilibrium constants for the individual steps. So if we have A plus B yields C, and then C plus B yields D, and these have 2 different constants, they're the product. So you're going to multiply those constants together. So consider the general equation. A plus B yields C plus D. The equilibrium expression is this. Since pressure is proportional to concentration for gases in a closed system, the equilibrium expression can be written similarly. The pressure of C times the pressure of D over the pressure of A and the pressure of B. So if we look at the ideal gas law, PV equals nRT, and we rearrange it to solve for the P, we're going to end up dividing both sides by V. So we get P is equal to N over V times RT. Plugging this into the expression of K sub P, so the equilibrium constant of pressure for each substance, the relationship between Kc and Kp becomes the equilibrium constant of P is equal to the equilibrium constant of C times RT to the power of delta N, where delta N is the number of moles of gas products minus the moles of gas reactants. The concentration of gas in a mixture is proportional to its partial pressure. The equilibrium constant K can also be expressed as the ratio of partial pressures in atmospheres of the gases. In calculating the equilibrium constant in pressure, the partial pressures are always in ATMs, atmospheres. For the chemical reaction, A plus B yields C plus D, where they're all gases, the equilibrium expression becomes P of C, P of D over P of A, P of B. The value of Kp and Kc are not necessarily the same because of the difference in the units is only when delta n is equal to 0 that the Kp is equal to the K of C. So let's take a look at this one. If we write the equilibrium constant ordinarily, you'd have NO2 to the second power into O4. But this question is specifically asking for it at pressure. So why don't we use this equation here? K of P is equal to Kc RT to the delta N. Kp is what we're looking for. Kc is given. R is the ideal gas law, gas constant. Notice it's in atmospheres. And then temperature is 298. That RT here is to the delta N power, which is 2 minus 1, which comes out to be 1. Multiplying this out, you find that Kp is equal to 0.14.